Welcome to Suzaran Nizam and greetings to my fellow friends. Today me and my group are going to present about battery energy storage solutions, or also known as BESS. And these are my group members.
Good evening to everyone, and today I'm going to present about the subject power system, and the title of that subject power system is Battery Energy Storage Solution BESS, driving Malaysia energy transition. The battery energy storage solution have emerged as an indispensable technology for modernizing power generation globally as Malaysians strategically shift towards renewable energy. Battery energy storage solution ensure electricity remains stable, reliable and efficient. And this presentation will explore the technology, strategic role and implementation challenge of BESS, focusing on how electrical engineers can drive the nation's ambitious energy through transition. To talk about the way of defining the battery energy storage solution, BESS is the grid power bank. BESS are sophisticated system designed to capture electrical energy from the grid, store it chemically and release it back rapidly when needed. This function is vital for managing the intermittency of solar and wind power. And we have a storage and discharge, like capture excess energy for later use. And the light of sun mitigates intermittency, that is like balance supply when renewables are offline. BESS align directly with Malaysia National Energy Transition Roadmap net supporting goal for a low carbon, secure and technologically advanced energy infrastructure. Lastly, the critical roles of BESS in modern power grids is about the shift towards high penetration renewable energy. System demands a responsive and flexible grid architecture, like managing intermittency. RE resources produce power only when conditions are right, like sun or wind. BESS stores surplus energy, filling the gaps during low production periods and ensuring continuous supply. And the second one is accelerating decarbonization. But it's like by making intermittent RE variable for BESS slot supply. BESS reduce the reliance on carbon-intensive fossil fuel generator, as turning the move toward clean power. And last one is about the balancing supply and demand. BESS can inject or absorb power in milliseconds, providing rapid frequency response and critical stability service faster than traditional fossil fuel generator. That's all from me, and thank you.
Good afternoon to Sir Sharon Nizam. My name is Danish Nazir bin Abdullah and my ticket number is 07DE 23F1045. Implementation challenges for BESS deployment. While essential BESS adoption involves technical and operational hurdles that engineers must address for successful projects. First, intermittency support. Designing control systems that effectively manage the highly fluctuating output from solar and wind farm is complex. Second, storage capacity limits. Batteries have fixed maximum energy limits, which necessitate precise sizing and strategic deployment to cover demand peak. Third, life cycle and degradation. Battery performance naturally degrades over multiple charge and discharge cycles, requiring predictive maintenance and replacement strategies. Lastly, safety risk. Potential for thermal runaway and fire necessitate stringent safety protocols, sophisticated cooling system, and robust enclosure. Addressing this challenge is key to developing safe, highly efficient, and long-lasting BESS installation. There are 5 extensive benefits of BESS to the power system. First, enhanced RE integration. Its smooth output variability from renewable source future upgrades. Third, frequency and voltage stability. It offers instant reactive power support, maintaining grid quality and reliability. 4. Reduce operational costs. It decreases the need to run expensive and inefficient fossil fuel vehicle plants. Lastly, number 5. Lowers carbon emissions. Facilitates the displacement of traditional generators, supporting climate goals. BESS is the backbone of smart grid strategies. BESS is fundamental to building smarter, more resilient and responsive power networks. First, demand response enable ownership and peak sharing via BESS, so that consumer adjust energy consumption based on grid signals, utilizing BESS to manage localized peaks and system stress. Second, hybrid system. It integrates renewable with storage for reliability. Seamlessly combines multiple sources like solar, wind, thermal with storage for optimized energy output and predictable supply. Third, grid automation. Support real-time control and grid orchestration. It integrates digital controls and real-time data to automate power flow, providing the necessary fast energy. Lastly, power factor. It corrects reactive power to improve efficiency.
Hello, my name is Muhammad Afrin Hadi, and now I'm gonna talk about advanced technology integrate with BESS. So first of all, we have SCADA integration. SCADA integration supervisingly control data acquisition system, able real-time monitoring and automate control of BESS asset for optimization. Second, we have load forecasting. Predictive analysis use BESS to strategically reserve power, ensuring system resilience and preventing costly blackout during anticipation high demand time. And third, we have microgrid development, critical for providing stable and independent off-grid power to remote and rural area, enhancing energy access and securities. And now part is for the environmental cost for conventional energy. So we have major pollution release and also local and global impact. So for the major pollution release, first they release a carbon dioxide, primarily drive for global warming. Second is sulfur dioxide, contributes to acid rain and respiration issue. And third, nitrogen oxide cause smoke formatting and environmental degradation. For the local global impact, air and water pollution directly contaminate for natural resource. Ecosystem destruction, acid rain and temperature shift distribute natural habit. And public health risk, increased rate of asthma, heart disease and other chronic condition in nearby communities. How best support a greener future? First, displacing a peaker plant. By restoring RE, best reduce a reliance on highly polluting fast start fossil fuel peaker plant during peak hour. Second, enabling high RE penetration. It make immediate solar and wind relevance, allowing utility to safely integrate much higher amount of clear power onto the grid. Third, reducing grid losses. BESS can strategically locate near demand center, minimizing transmission distance and enhancing overall system efficiency. Fourth, lowering GHG emission. The cumulative effect is significantly reduced in overall greenhouse gas emission across the power generation sector. So this part I'm gonna talk about industry insight and global case studies. So first we have solar plus storage microgrid. Commercial and industrial facilities used by BESS for backup power, demand charge reduction, and maximizing self-consumption from the rooftop solar. Second, utility scale battery farm. Large-scale lithium-ion facilities are developed globally to provide grid stability, frequency regulating, and bulk energy shifting. Third, rural electrification. BESS ensure stable and reliable off-grid energy supply in remote area, eliminating the need for expensive and unreliable diesel generator. And fourth is smart city energy system. Integrating BESS with EV charging infrastructure and smart distributing system optimize energy flow and resilience in urban environments.